Hello everyone. Uh, Here we are interested to find out the voltage V0 here, which is across the resistance 8 ohm, and for that we are interested to use the source transformation concept. Remember, the same voltage can be found out by some another methods also, but here we are interested to solve this using the source transformation concept. Okay, so let us go for this using the source transformation. So first of all, what we should do is we should convert this combination of a current source and a resistor into equivalent voltage source, right? And for that, what we can do is, let me take this circuit on the other side so that I can use the same circuit for further proceeding. Just give me 1 second. So here is copy, then paste. So yes, now the same circuit is available here, and as I said, so we are now we will be converting this 4 ohm and 3 ohm combination into a single voltage source. So for this, the voltage source which we will be having will have voltage value V is equal to 4 ohm into 3. So it is means 3 into 4, it will be having 12 volt. So equivalent voltage source which will be having here is the 12 volt, and the resistor, this 4 ohm resistance, will come in series with that. So let me do that here. So this 4 ohm will, once again, this 4 ohm resistance will go in series, and what we'll do, we will replace this 3 ohm current source by this equivalent voltage source here. So here we will be having the voltage source. Means what we did, we have just converted this particular combination of current source and the parallel resistance into a series voltage source. So here we'll be having how much? So as we calculated, it is the 12 volt. Okay, now what about the polarity? Remember, the current polarity is like this, so that's why voltage polarity will be lower side positive and upper is negative, right? So we have converted this particular combination into its equivalent voltage and resistance. Okay, now remember, here we are interested to find out this voltage V0. So we will not disturb this 8 ohm resistance in the circuit, rather we will keep it as it is and try to convert the remaining circuit into a single voltage and single resistance, or single current and single resistance terminology, right? So now further what we can do is, we can replace this 4 ohm and 2 ohm resistors and keep a single resistor here which will be series combination of 4 ohm and 2 ohm. So now just replacing this 2, what we can do is, we will have the single resistor here. So what I can do is, I can just replace this portion this particular resistor is now replaced, and what in place of this 4 ohm resistance, what I can write here is just a 6 ohm resistance here. This is 6 ohm resistance, right? Because the 4 ohm and 2 ohm, now they are connected in series, right? So now this newly generated circuit is having 12 volt supply here. In series with that we are having 6 ohm resistance, this 12 volt supply and 3 ohm resistance, right? Now as decided, we are not going to disturb this. So what we can do, we can again convert this voltage source and series resistance into a equivalent current source, and similarly this voltage source and resistance will be converted into another single current source and a equivalent resistance. So the equivalent voltage the equivalent current source for this combination will be let us say I1 will be equal to this 12 volt divided by 6 ohm, it will be 2 ampere. So what I can write, in place of this whole combination I am writing here single current source, right? This is single current source. Again see the polarity, this is minus plus, means plus on the downside and minus on the upside, so polarity is like this. Now the resistance of 6 ohm is now coming in parallel to this current source. So this is the 6 ohm resistance, and how much is the value of this current source? This is 2 ampere, right? Now further, this 8 ohm resistance we will be keeping it as it is. So this is as it is now. This is the 8 ohm resistance across which the voltage V0 is to be find out, right? And what about this? Similar to the previous one, this voltage source will be converted into a single current source equivalent. So how much will be the value of the another current source? So it will be, let us say I2 will be equal to again this voltage source divided by the resistance. So it is again 12 volt divided by 3 ohm, so it will be again 4 ampere, right? So again we will be having here the another current source in we okay, one second. Yes, we will be having the another current source once again, and this is the current source. Again see the polarity, this is positive and this is negative, so the direction of the current source, or this which we can call as I2, will be like this. And this is how much? This is simply 4 ampere. Okay, what about this resistance? So that 3 ohm resistance we will be keeping in parallel to this current source. Okay, so this is again 3 ohm resistance. I hope you understand up to this particular point, right? So now let me remove this particular circuit in order to get the space for the further work, right? So now, yes, now further what I need is, we are interested to find out the voltage. One second. Yes, we are interested to find out the voltage drop across this 8 ohm resistance. This voltage we are interested to find out, right? So as decided, we will not disturb this 8 ohm resistance. So what we are going to do, we are going to convert this current source, two current sources, into a single current source. So this is a 2 ampere current source with this polarity. This is 4 ampere current source. If we combine them, we'll be getting another current source, and it will have the polarity like this, right? And what will be its value? So it will simply 4 ampere minus 2 ampere. So in this way it is just a 2 ampere. So this is the current source of 2 ampere we are having here. So the two current sources are replaced by a single current source. Now this 6 ohm resistance and the another 3 ohm resistors, these are also coming in parallel. So what we need to do is we have to replace them by a single resistance. So that resistance can be called as the R equivalent. So it is R equivalent is equal to the parallel combination of 6 ohm and 3 ohm. So 6 and 3 ohm resistance, when come in parallel, we will get it equal to 6 into 3 divided by 6 plus 3, right? So this will be simply 2 ohm resistance, right? So now we can put here a single resistor which is having the value of 2 ohm, right? So in this way the total circuit is replaced by a single current source and a single resistor, and what remain is this resistance of 8 ohm, across which this 8 ohm across which the voltage we are interested in measuring. Now further here we can have the different approaches to find out the voltage across the 8 ohm resistance. We can go by the current division rule, but now yes, we can go by the current division rule, or we can further convert this circuit, which is consisting of 2 ohm resistance and 2 ampere current source, into a single voltage source. So if you want to convert it, so again this can be replaced by a single voltage source whose voltage will be equal to this 2 ampere into this 2 ohm. So it is again 4 volt, right? So now we'll be having the another voltage source here which is having the value of 4 volt. Again the polarity is this, right? What about the resistor? The resistance of 2 ohm, which was in parallel with the current source, as we have transformed this current source into a voltage source, this resistance should be shown in series now. So now this is a 2 ohm resistance, and now ultimately we have the final circuit, we can say, where this 8 ohm resistance can also be shown. So this is the 8 ohm resistance across which the voltage V0 or V, let us say this is V0, is to be measured, right? And now we are moving towards the last step probably, wherein we can simply consider that this is the, say, current I which is flowing through the loop, right? So if you want to find out the value of this current I, we can write it I is equal to the voltage in the circuit, that is 4 volt, divided by total resistors in the circuit. So it is 2 ohm plus 8 ohm, right? This 2 ohm and 8 ohm resistors are coming in series. So in that way, the current which is flowing through the circuit will become 0.4 ampere, right? Now what we were interested to find out, we are interested to find out this voltage V0. So the voltage V0, which is the voltage across the resistor 8 ohm, can be given like I multiplied by the value of that resistance, that is 8 ohm. So what is the value of I? This is 0.4 ampere. So it is 0.4 into 8, and which comes to be 3.2 volt. So in this way we can say that the current, the voltage drop across this resistor 8 ohm in this is 3.2 volt.